Welcome to Made-in-Alberta. I'm Barb Allard, and this is our chapter called Water and Weather. Every summer, Rocky Mountain glaciers melt and fill our rivers with cold, clean, fresh water. Snowfall builds them up again, and so an equilibrium has been maintained, until recently. Alberta's climate is now 2 degrees hotter on average, and our pattern of snowfall is changing. To learn more about the implications of this, we met with a scientist whose specialty is the relationship between glaciers and the climate system.
What we're interested in is really understanding how glaciers and ice sheets respond to changes in the climate and what the consequences of those changes might be for global sea level and for water resources.
Global warming can affect glaciers in 2 major ways: by changing the length and intensity of the melt season, and by changing snowfall patterns.
We suddenly increase the air temperature by, say, 2 degrees in summer. Well, the glacier will start to melt more rapidly. And if we don't increase the snowfall to compensate for that, then in the long term that'll mean the glacier starts to shrink.
So a slight heating of the atmosphere changes water, weather, and other natural systems that Albertans rely on. But it gets worse because built into the climate system are feedback effects, natural responses to these changes that cause further changes.
As the glacier starts to shrink, ice-covered surfaces get replaced by bare rock or soil or whatever, which absorb more solar radiation. That heats up the surface so that it emits long-wave radiation back to the atmosphere, which can get trapped by greenhouse gases, which then tends to result in a warming of the atmosphere. So we don't actually have to have done anything externally to make the temperature increase. It's just because we're removing the ice, changing the nature of the surface, we're getting an enhancement of the warming.
The glaciologists have recently discovered bacteria living underneath the glaciers. They're trying to determine what sort of warming effect this will cause.
It might be that you could envisage these large ice sheets as kind of a giant composter where you put the ice down on top of all this dead organic matter, and then there's a microbial ecosystem which establishes itself to use that as an energy source, converts that carbon into carbon dioxide and methane, and the question is that just stored underneath the ice sheet until the ice sheets melt and then released back into the atmosphere, or can it be kind of dissolved in meltwater flowing underneath the ice sheet and then transported out to the atmosphere on a kind of steady basis?
A third feedback effect works on the glacier itself. As it shrinks, it tends to move from higher and colder elevations, where there's more snowfall, to lower and warmer elevations.
You get another feedback where the rate of melting is accelerated. So a very small perturbation in the first place, which puts the system out of balance, can get amplified by these kind of feedbacks. So we get a much bigger response than we might initially have expected.
Join us again in Water and Weather for part 2 of Dr. Sharp's interview and further discussion on the probable effects of global warming on Alberta's freshwater resources.